A 12-person crew has kept a week-long vigil, while the barge, carrying with E.T., made the 900-mile trek from Louisiana to Florida's central east coast. The iconic orange external tank finally arrives at the Kennedy Space Center. 1 month later, the E.T. is mated to the solid rocket boosters to form the backbone of the stack. Now, all that's missing is the spacecraft itself. When an orbiter returns from a mission, processing for the next flight begins almost immediately. It's a task requiring no less than 650,000 hours of labor. This includes the removal of its 3 liquid fuel engines and their replacement by 3 from a previous mission. They've been refurbished, inspected, and tested at the Stennis Space Center. With most of its flight preparations complete, Endeavour is towed in what is called the rollover, a short roll over a quarter-mile distance on a 36-wheeled vehicle from the Orbiter Processing Facility, the OPF, to the VAB. Here it undergoes its flight configuration. The rollout. Looking now much like it will at liftoff, the space shuttle is carried to the launch pad atop the 6 million-pound crawler transporter at a blazing pace of less than a mile an hour. Not exactly warp speed.
At our peak carrying full load, we get right around 38 feet per gallon.
Not too bad for an original 1965 hybrid vehicle with low miles. The 3.4-mile journey takes up to 6 hours. Just enough time to appreciate the route's picturesque surroundings. Kennedy Space Center is situated on a national wildlife refuge. Bald eagles, osprey, and vultures are just a few of the scores of bird species regularly spotted in local skies. Both land and sea are home to a wide variety of creatures, including manatees, dolphins, and of course, the ever-present alligator. Visitors are always urged to watch their step. Now on the launch pad, the orbiter is ready to take on its main payload. Testing assures that the multi-ton cargo is secured and safely stowed in the payload bay before the technicians certify the orbiter is ready for launch. Flying T-38 aircraft from Ellington Field in Houston, the crew members arrive at Kennedy's shuttle landing facility.
But finally the day comes when you're there and you're getting ready to launch. And you go into launch countdown and it's like going up the hill on that roller coaster. It's full of expectation and you're both thrilled and terrified at the same time because anything could go wrong, but when it goes right, it's a thing of beauty.
If there are no issues or concerns, technicians begin fueling the external tank with volatile liquid hydrogen and oxygen.
The predominant emotion is pride. There's a tremendous sense of pride in all that not only that you do, but that your teammates do, that people in this very firing room do, and folks all across the country.
This is shuttle launch control, T-minus 9 minutes.
At the T-minus 9-minute hold, the launch director leads one final pull.
We finally come out of the hold at T-minus 9 minutes. I sit back and I watch my data, but I know that there are souls on board that ship whose lives are depending on the launch team to make the right decisions. It's, I don't think about that consciously, the decision-making authority and responsibility. I know it's there, but I do think consciously about the crews and the people we're about to put on top of a controlled explosion and get to orbit.
This is the NTD conducting the launch status check. All stations verify ready to resume count and go for launch. OTC, OTC go. TVC, TVC go. ETC, ETC's go. LPS, LPS is go. Houston flight.
Houston flight is go.
After nearly 3 years, hundreds of thousands of hours logged by engineers, technicians, scientists, seamstresses, electricians, and other program workers across the globe.
We have main engine start. 2, 1. Booster ignition.
The shuttle makes its way skyward. At liftoff, 6.6 million pounds of thrust begin hurtling the vehicle and crew at speeds that'll reach 17,500 miles per hour. The shuttle is like no other machine ever built. For its launch to succeed, more than 1 million parts must move together perfectly. How this engineering marvel came to be is an amazing story that begins in the early 1970s. The Vietnam War is divisive and costly. The economy is sliding into recession. And with the race to the moon already won, the Apollo program is canceled. A new mission is sought for NASA to send humans into space. But Mars, for many the next logical step on the path of exploration, is dismissed as too costly, a destination for a country preoccupied with events back on Earth. Instead, on January 5th, 1972, another destination is selected, low Earth orbit. As early as the mid-1960s, NASA had concluded that the technology was available to build and fly a reusable spacecraft.
President Nixon really liked the idea and told the NASA administrator, go do it. And the NASA administrator got a call from OMB the next morning, someone there, and said, hey, what the president really meant to say was, you're going to get this much money, and so do as best you can with the space transportation system. And our choice, logically, was, well, you have to have a vehicle first, and so that was the birth of the space shuttle as the first in the 3-part space transportation system.
Many designs were considered. Often, they combined the best features of different concepts.
At that time, they were looking at having jet engines on the shuttle for landing and for transporting it across the country.
The idea of the lifting bodies was to bring astronauts home to conventional runway landing. Previously, all of our spacecraft, which were capsules, came down in the ocean. Someone came up with the idea of a vehicle that could land like an airplane.
The key thing was to understand aerodynamic stability across the hypersonic, supersonic, subsonic, and landing speed type of environments that a single vehicle has to fly safely. That was the key thing that was learned from those, and you'll see it reflected in the shape of the space shuttle.
One was the use of a lifting body, an aircraft with no conventional wings. Only its fuselage would keep the aircraft airborne and guide it safely back to Earth.